Learning checkpoint 4.3. Number 1 says, what is the base of the exponential function f of x equals 0.5 to the power of x minus 2? Remember that the base of an exponential function is whatever value is attached to your exponent. So that's your hint for number 1. And then number 2 says, now that you found the base of the exponential function, does the function represent growth or does it represent decay? So you're going to look at your base, that's this value that's attached to the exponent, and you're going to figure out if your base is between 0 and 1, or if your base is larger than 1. If you are between 0 and 1, that is decay. And if your base value is larger than 1, that is growth. And that hint is also down at the bottom of the page for you. Number 3 and 4 are about the domain and the range of the function. So this is the same function that you were given in number 1 and number 2. This time you just see the graph or the picture that's represented by those values. The graph will help you find the domain, and your hint says the domain is all of the possible x values for the function. So think, what kind of numbers can you plug in for x? What kind of x values do you have that exist on your graph? So remember that graphs go on forever and ever in both directions. So you can actually come in here if you want to and add some little arrows to show that it's going to keep going forever and ever in both directions. We're going to figure out what type of x's we have. We can either have all real numbers, which would be anything on the number line. We could have all real numbers greater than 0, which means that you only have positive x values. Well, let's go check that out real quick by looking at the graph. Think if you only have positive x values on this graph. If I only had positive x values on the graph, then this would be the only piece of my graph right here that I just traced in orange. Well, that's not true. I have some graph in other locations, so it's not all real numbers greater than 0. I do have some other x values that are allowed to be on my graph. Integers are your counting numbers that you can count on your fingers and their opposites. So that would just be 1, 2, 3, 4, 5, 6, and their opposites with nothing in between. So go look at the graph and think, are my x values, or does my graph only exist at the point 1, at 2, at 3, or do I have some graph in between? And then your last answer choice says all real numbers greater than -2. So if I go to x equals -2, and I only want the portion of the graph greater than that, that would just be this part of the graph right here that I traced in orange. Well, if you look, that domain completely leaves out all of this part right here of our graph. So that is not going to be the correct answer choice either. So I'm going to leave you to choose between all real numbers or integers. Number 4 can be worked out in a very similar way, except we are looking for the range, which is the y values, not the x values, the y values. So now let's look at where the graph exists up and down. Does the graph exist for any single possible value of y that you can think of? Does it exist for only positive y values? Does it exist for only your counting numbers with nothing in between? Or does it exist only when y is greater than -2? So go through, you can find those different locations on your graph and see where your graph exists. Number 5 says the y-intercept for the function is the point 0, -1. Your y-intercept is the place where you cross the y-axis. So we are going to go through and just find that location. The y-axis is the up and down axis, and so your job is to label this point. Remember that we label points with their x-coordinate first, then the y-coordinate. And you'll either select true or false if that pink point is 0, -1. And then similarly on number 6, we're looking for the x-intercept. And the x-intercept is the location where we cross the x-axis. That would be this point right here. And again, we label points with their x-coordinate first, then their y-coordinate, and so you will select either true or false if this point is 0, -1. And just a hint, they can't both be 0, -1. This point or this point. They're not both going to be the same. That's your hint. They will not both have the same answer. Number 7 asks you about the end behavior of the graph, and your hint says, to find what happens when x increases, follow the graph from left to right. So let's go ahead and do that and see what happens. Our choices say that as x increases, our graph can either approach the line y equals -2, the graph can increase, or the graph can decrease. So let's go see what happens when I trace the graph from left to right. So I'm going to start on the left side of my graph, and I'm going to follow it to the right side. Now the picture that I have snipped on the board right here actually doesn't give you the full picture that the graph in your OHS will show you. So when you're doing this question number 7, please look at the graph that's in the actual checkpoint in the OHS because I had to cut my snip off to fit it on the page. There's more to this graph that might give you a little bit better picture of what the end right here of the graph is actually doing. So if I read the graph from left to right, I notice that I'm going down, I'm decreasing, and then the graph kind of starts to level out right here. You'll see that better in your OHS. When the graph levels out, we have a special type of line that our graph is approaching. The second thing that you will select is the end behavior when x decreases. So that means we're going to follow the graph backwards from right to left. So if you start over here, and in class we talked about it like a roller coaster, so you get on the ride. Let's see what happens. If I start on the right and I ride this way, let's figure out what we are doing. Are we approaching a line? Are we increasing or are we decreasing? That's what you'll need to determine for that one. So start on the right, follow the graph, and you will select which one of these options is correct for that. And the last one, number 8, says, find the average rate of change of your function from x equals -2 to x equals 0. So you are selecting just a specific little slice of your graph and figuring out the slope of that little slice of your graph. So between x equals -2 and x equals 0, I'm really just looking at this little section of my graph right here, and I'm trying to figure out what's happening to the slope of that little section of my graph. I don't care about the rest of it, I just want to know what's going on right here. So what we can do is use the graph to help us. Your hint and your steps are down below. You're going to start by evaluating the function at x equals -2. So we can either plug in -2 or we can just go look at the graph. When x equals -2, we are at a y value of +2. And we're also going to evaluate when x equals 0. When x equals 0, my graph is at the y value of -1. So you're going to take these values and plug them into our slope formula and simplify all the way to see what you get. So it doesn't really matter which one you label which, as long as you're consistent. I'm going to call this x1 and y1, and this one x2 and y2, so that you can take your numbers and plug them in to this formula, simplify all the way to see what you get. And if you're unsure if your answer should be negative or positive, if that's something that trips you up, take a look at how this little section of our graph is going. Read it from left to right and see if you're going up or down. That will help you decide if your overall rate of change or slope should be negative or positive.